So far you have seen sweep and close surface and fill and join and revolve. Let me show you a multi-section. I also showed you how to do surface measurements, although I can show you how to create the perimeter of a surface too. So let me show you. Here. So let's say I go on this plane and I create a centered rectangle, and then I can fill it if you want. Now somebody might say, what is the perimeter of this surface? Not the section area, because once you click on the measurement and click on the surface, it gives you the area, right? But sometimes in some CATIA certificate exams that I have seen, somebody asked for perimeter. Now here I activated the perimeter, but by default the perimeter is not there. But if you want, you can go under customize and activate it. So here, if you go under surface, you see I have checked this option says perimeter. But by default, this option is not there. So when you click, all that you get is the surface area here. But as I told you, you go to customize and then you activate what you want to really measure. So for a surface, I also want to be able to measure the perimeter. And now you see, I can also get the perimeter of the surface. So now let's go to a plane parallel to this guy. And on this one, I would create a circular surface. I can fill that out as well, right? And now I want to create a multi-section that connects these two together. By the way, when you want to connect with multi-section, you don't need to fill them. The only reason I fill them, I want the whole thing to be a closed surface. So now I click on the multi-section and it says, what are your curves? I say, this is one of the curves, this is one of the curves. And again, you see you have the same issue of closing points not being in front of each other. So you might get a what? You change your coupling to ratio. If you say preview, you would get it, but you might get some twist, which I do a little bit here, right? But I showed you how to move the closing points and replace them. And once you do that, then you have your multi-section. And then here, again, you can click on these two fills and multi-section, and then what? Join them all together and get yourself a what? Something like this salt shaker or so, right? So this is how you create a multi-section. Now, the other thing that I wanted to tell you from that BITW toolbar that is not here is, let me see if I can get it here. One of the commands in this toolbar is for creating holes on a surface. So I can click on this and then say I want to create a hole if it allows. So here you need the center point and you need the support surface and so on and so forth, right? So my center point, I can say I want to create that, and then I say I want to create it on this surface, and then I put it, let's say here. Okay, and then the support surface is of course this surface. The orientation you have to provide here, it's going to be x-axis, and the same thing for punch direction. Then you can provide the shape, whether you want the shape of the cut to be a rectangle, whether you want it to be square, whether you want it to be a slot, and so on, right? And you can provide the size here. And if you look at the preview, let me see if I can show you where that hole is. Oh, I guess I created my surface, my center point somewhere else, but you can clearly see the cut here. So all I need is to move my center point to somewhere appropriate, right? So if I double click on this for the center point, I need to basically edit this guy. As it says on the surface, fine, but you have to make sure that you put it where it is appropriate. So maybe I do it on this second fill if it allows me to. The problem is when you join them, then those separate components are not recognizable by CATIA. The whole surface is recognized. So now you really have to basically do a hard adjustment job. So you see here, it looks like I moved it to this top surface, but I didn't really. It moved to somewhere else. Okay, so this adjustment is not necessarily simple unless, again, you know your coordinates. So maybe instead of that, I say I want to use coordinates. And then for the coordinates, I can provide for X direction 5 inches, so it is on this front plane, and then I use 0 and 0, right? So now it's exactly at the center of the top surface. And there we go. Right? So you can punch a hole with different shapes, circular, rectangular, square, or slot, on a surface. Okay, so I showed you that command too. And I showed you multi-section and measurements. Now, as I said, you can mirror your feature, you can scale it, you can rotate it, and so on and so forth. So let's say here, I got this surface with this hole, and then I find out that, well, I want this to be bigger. I made this part smaller than what I really needed to be, so I want to make this bigger. How do I do that? So if you go to this operation toolbar here, if you go down here, the second item from the bottom, if you look at it, you can translate the surface, rotate the surface, do a symmetry. Now remember, symmetry is different than mirror. It transfers it from one side of a plane to another side. You can scale it, or you can do affinity. And if you remember, affinity is a non-uniform scaling. So you can basically scale it in different directions differently, right? So say, hey, I want, let's say my origin to be the point at 0, 0. Then the XY plane to be the typical XY plane, and the X-axis to be the typical X-axis. Then in the X direction, I want to make this 1.5, so I want to make it longer. And then along Y and Z, I just want to make it a little actually smaller, so I want to make it 0.8. Then in this direction, I want to make it like 0.7. There we go. Okay. Now note that this guy will be created in addition to the original one. So if you don't want the original one, just hide it. Okay, so you see that I applied an affinity scaling, which is non-uniform scaling, and scale it in different axes, along different axes differently. Okay, and as I said, you can rotate, you can transfer, you can do whatever that you want. So maybe I want to transfer this. I want to transfer it about the y-axis, and I want to transfer it 90 degrees, or negative 90 degrees. And there we go. Right, I made it vertical, and again I can hide this. Right? So I can do any transformation that I want. We'll talk about extrapolation next, but this is some basic thing. Now let's say I made this slot and I want to repeat this feature. Let's see if it allows me to repeat it. So if I go back to this original thing, let me get rid of this rotate and affinity and so on. Go back to whatever I had. Now, so I made this punch, this hole, and now I want to repeat that along some directions, right? So how do I do it? That's where this toolbar comes in with the pattern. So you can do rectangular pattern, circular, or user. So let's say I want a rectangular pattern. So it says, what is it that you want to repeat? So I want to repeat this hole. And if it allows it, let's see, and then reference element, I choose maybe z-axis. Now here, it is really going to do the whole object for you if you cannot separate the whole, if you cannot create the whole separately. So it is right now going to, because this hole is added to the join, therefore you cannot really repeat the whole individually. It is going to repeat the whole entire surface. So if you want that hole, you have to first create that hole on this surface, repeat it, and then join them together. As I said, right now, if you say repeat, even though you are selecting this slot, since it's attached to the rest of the part, the whole thing will be repeated for you. So let's say if I want to repeat this object along the y-axis, right? And then I say I want like 4 of that with a spacing of 8 inches each. Okay? So I'm gonna get 4 of the whole thing. But you get the idea that if you want to repeat something, as with part design, use the rectangular pattern or circular or user define. Okay. Now, another very nice command that I really like in surface design is extrapolation. So when you have a surface, you can extrapolate it and continue that with different conditions. So let me show you that one, because that is a very good command. So here, let's say you have a hemisphere, right? So let's go ahead and create a hemisphere. And we rotate this but 180 degrees about this axis, right? So I got myself a hemisphere. And now I don't want to make it a complete sphere. I want to basically extrapolate this surface with this boundary using different conditions. So I click on the extrapolate and I say I want to extrapolate. It says, what is the boundary? I said, this guy. What is your surface? It recognizes. And then you can basically provide different conditions. Okay, so here extrapolated is revolute 1. I can provide more length, right? And if I say the condition for extrapolation is continuity, means what? Continuity is tangent, means how would you continue that surface? How would you extrapolate it? Whatever the tangent was, which at this boundary the tangents to the surface are in the x direction, continue the rest of the surface in the x direction. So make sure the tangent to the new extrapolated version and the old one, the tangent vectors here at this boundary to the both surfaces are the same, okay? The tangent lines are continuous, they are the same thing at the boundary. But maybe instead of tangent line, you say, no, I want the curvature to be the same, right? Then the curvature here for this surface and this surface at that curve is the same. So you would get what? A portion of the rest of the sphere, right? And if you change the length, then you can change the amount of continuity. Okay, how far you would go forward. And look, now I can get this shape. So this surface extrapolation can really give you power to create more complicated surfaces. Then we can cut surfaces by other surfaces, and we can get the boundaries of any surface if we want to. So here I have this extrapolate, which is the whole thing, and somebody says, I want to use this boundary. Okay, I want to use this boundary for some application. Can I just get this 3D curve? And the answer is yes, you sure can. Where is that? It's under wireframe. So you see here was the projection, the second was intersection, parallel curve, right? So you have a bunch of different things. Actually, the one for boundary is under operation, sorry. So it's right below the split. So I click on the boundary and I say I want the boundary of this guy. And look, it gives me what? It gives me that boundary as a curve that now I can select and do something with it. Do you think we can fill it? Let's see what happens if we do fill. Yeah, do not expect to get what? The rest of the sphere back, of course, right? Because the fill command does not know really that it was a part of a sphere. You can put a passing element and control this a little bit, but it is not going to give you the perfect thing, right? It's not going to give you the rest of the surface back. If you wanted it, you had to extrapolate the spherical part more, okay? But yes, you can really use that as a closed curve and fill it if you want to. So that's about getting a boundary, and then as I said, you can create another surface and then cut this surface with the other one. So not only you can cut a solid part with the surface, you can also cut a surface with the surface, or even cut it with a plane if you want to. So let's say here I go on this plane and I create another surface. Like that. Then I extrude it and make sure this new one cuts the old one all the way into two portions, like that. And now, remember, we had a split element and we have a trim element. So, okay, so I say I want to trim this surface with this guy. Okay, and then, again, as I said, the part that goes kind of opaque, that is the part that, or semi-transparent, sorry, semi-transparent, that is the part that is going to be eliminated. So if I want to keep that bottom part and get rid of this top part, I say other side. Okay? Or I can do the other one too. I can also use this bottom surface to cut the other one too. So you can use each one to cut the other one. Okay? So it's up to you how you want to trim one with the other. So here, as I said, I want to trim this with that, and I want to keep the bottom part, eliminate the top part. So here, not deleting the right one. This is good. Yeah, that one is gonna go. And I okay that. Then I hide this guy that I don't need anymore. Oh. Okay. So what I did here is basically trimmed the two with each other, right? So now I have this and a weird shear surface, but as I said, I can eliminate anything else also that I want. So I eliminate that and eliminate this like that, correct? And then I get this one. Yeah. So if you want, you can make them. Let me change the sketch and draw a line from here to there, and use the trim tool, something like that. Make sure these are coincident really. If not, you can always fix it, but I guess they are now. And look, go ahead and hide these guys. Yes, you see, I got myself this other complicated shape. So I used one surface with the other and trimmed both of them. Or as I said, I can cut the whole thing and use a plane to cut it. So let's say here, this is this whole surface. Now I can cut that with this middle plane too. So I say I want to trim this whole object using this plane, if it allows me. If it doesn't, then you have to use it as a cutting element. Okay. See if I can split it by that. Yes. So I would split and just keep this part. There we go. Yes. You see? Now this is what? This is empty. So I can fill it out using the fill command. And I say this is the closed curve. And there we go. Okay. So now you see I can create anything, any surface that I want when I know how to use the combination of split, trim, and fill, extrude, extrapolate, and so on and so forth, right? The surface design basically has no limitation on what you want to do with the surface. You can create whatever you want. And now you might say, I want this edge to be rounded. That's a sharp edge. Can I make that round? Sure, why not? Use a what? So here you have the shape fillet and the edge fillet. Say I want to fillet this edge if it allows. Okay, support is this way. It doesn't recognize. Let me use this guy here and choose this one. Okay, so this one needs two supports. So first let me see. Yeah, because the fill and the split are two separate things. Let me first join them together like that. And now let's see if we can use the fillet edge command. Select this edge and provide a radius. And there we go. Okay, so one of the things is, one of the other applications of join is when you want to apply the edge fillet, you need to apply it to a join. You need to apply it to the edges of a joint, not individual components. Okay, so here you see I could easily create a what? A fillet, or I could do a chamfer on it. You can also create bumps in the surface, right? So I can go ahead and create a local deformation, a local bump. So here you need element to deform, deformation center, deformation direction, and if there is a limit curve, right? So the command for that is in this toolbar here, and that is this top command. So see if I can create a local bump. So if this is like a helmet, right? This is a local bump. The biker hit his head somewhere, and there is now a local bump. So we say this is the element to deform. The limit curve, let's say if I can choose this guy to be the limit curve, and then deformation center, I create a point on the surface, and let's say that point there. And the deformation direction is gonna be in the Y direction here, and you can provide the amount of deformation. The problem is this curve, the limit curve, it wants it to be a closed curve, right? Right now it's not. So before I can do this command, I need a closed curve as my limit curve. And so again, I need to use that boundary command, right? Remember, we had the boundary command, which gives you the boundary curve of a surface, which is this guy here. So let's see if it allows me to. I don't think it does. Let's see if I go back, can I? Probably not, but and I guess the reason is because of the fillets, but let me try it one more time. Okay. Yes, because of the fillet, it does not allow me to do it. How about now? No, because you have this guy here. That guy is the reason for not getting you a single closed edge. Okay, so here what I do is, let me get rid of all of these trims. Make life a little bit easier. Can even get rid of this one. So let's say I have this, and now I go ahead and click on element to deform, then the limit curve. Now here, if I choose this, this is a closed curve. Or at least I hope it takes it from me, otherwise I have to go and create one. And let's say I look from direction, I can put it somewhere here. Then for the deformation, I here choose perpendicular to that, which is x-axis, and then let's see. Yeah, it does not like it because the curve I gave it for the limit curve is not closed. So the first thing I want you to know is, when you get an error like this, don't be disappointed and don't be frustrated. Try to find the reason that the error is showing up and try to eliminate it or fix it. So here, as you could see, when I said I click on this edge, it just took half of it instead of the whole thing. So now let's see if I can use the boundary command and get this. Now this is a closed curve. Hopefully this one can be chosen and used. So I do it again, this one, and then the limit curve. Now I choose the boundary. This is a closed curve. The center, I say I want it on this surface. Then I'll try to put it anywhere that I want. Let's say bump here. And then the direction for the bump is x-axis, and then some, there we go. deformation, right? So whatever you want, you can create. Okay, something like that. Okay, so you can create a local bump in the surface. Okay, I guess I talked about filling, joining, fillets, and chamfer. The other thing you can do is to create offsets from surfaces. So let's say here you have this spherical surface, and then you want a replica of that with some offset. So you go and click on offset surface, and then you choose the surface to be repeated, and then you provide the offset. Let's say I want 1/2 inch gap, right? And then if you see the preview, there we go. So now I got this, and if somebody says, okay, could you now fill this area in between them, right? Could you fill this area in between them and make it a closed object? Can you do that? Because as you saw, when I want to create solid objects, most of the time I need a closed surface. So the answer is yes, I would use the fill command here. Okay. So I bring this guy back and I use the fill command, and it says, what is your outer boundary? I choose this guy. It should be closed edge. And what is your inner boundary? And then I choose this one. And now look, there we go. Right? So the good thing about the fill command is you can choose inner and outer boundary, but both of them have to be closed. So I could make this object. I can join these three surfaces together, right? So I say join, then I join the revolute, the offset, and the fill, make one single join surface. Now I can take this guy to part design and use closed surface to convert it into what? A solid object. So I got this like half coconut object. Okay, so this is creating basically offsets. Okay. One more thing, a very powerful command in surfaces, which is really powerful actually, is blending surfaces. So if you have disjoint surfaces, you can blend them together and you can try to create a smooth joint surface as much as possible. Let me show you an example of that. So here, if we go to generative shape design again, I go ahead on this surface and create something. Let's say an ellipse. Then I extrude this guy. Right, then I create a plane. Then on this guy, I create another curve. Let's say a different one like this. And guess I canceled it. Let me create another one, as I said. Then I extrude this guy too. Okay, so I have two disjoint surfaces, and these guys are completely separate. Their end profiles are not even on the same plane. And now can I connect them together in a smooth way? Because multi-section, you might say use multi-section. Sure, I can use multi-section, but the multi-section is not going to be so smooth. In other words, this surface, this one, and the multi-section are not going to be like super tangent to each other. I'm going to have sharp edges here and here. Is there any way that I can connect them together in a smoother, in a better way? That's where I use this command blend. By the way, I need this curve here also, so I use the boundary command and I get this curve because I need it. So here it says, what is your first curve? So this guy, what is your first support? This one. What is your second curve? This guy. What is your second support? This one. And now it says how you would try to create the surface. What conditions do you have? So you see here you have more controls, right? It's not just simply connecting points with a line and creating a multi-section. You have a lot more control here. Like what? Like the condition for the endpoints. Okay, so here you see I can say I want the curve here and curve here, or the surface here and the surface here, to be tangent to the blended surface or have the same curvature to it, how much is the amount of tension on them, and so on. So here you have control over how you change the tension in the surface and change the shape of it. So let's say I want at both ends to be what? Tangent. And there we go. Look. What's the difference between this one and a multi-section? As I said, the multi-section will create direct lines and will give you something that has sharp edges here and here, but look at this one. You don't see that. It's like not only it has the two profiles, it will create for you the lateral guides to make it what? Tangent here, so you have a smooth surface here and smooth surface there, right? So this is really great for connecting disjoint surfaces, blending them together, and create more complicated surfaces. And as I said, you have control over this. So if I want to change the shape, one of the things I can do is tension. So look, when I change this from 1, which is max tension, to 0.1, which is min tension, the shape does change. You see? So when you make it 0.1, basically you are trying to minimize the amount of tangency area. So there is a tangency, but it's a small area. But when you say no, pull it as much as possible and make the tangent area as big as possible, then you see you're extending here the tangent area and making it smoother basically, right? So you have control. Or you say I want the first continuity to be based on curvature, right? Let's see if it allows it. Yes. So now it tries to keep the curvature in this area, and then it tries to keep the curvature in the second area too, right? So you have more control over how to form this blended region. So I recommend using this command way over multi-section if you can. Okay, so I guess I talked about surface trim, and I showed you how to split objects, and I also mentioned closed surface, right? Now, as I showed you in the past, we can create a helix, right? Which is a 3D sketch which we need for creating threads. But we can also create 3D circles, 3D Espalines, and we can create the spirals. So if you want more complicated 3D shapes and even a spiral, which is 2D, we can use this generative shape design. Okay, so let me show you those. So remember the helix, or sorry, the Espaline that we made in the Sketcher workbench, it was a 2D. All of the points were on the same plane. But somebody might say, can you create a 3D Espaline? And you say, sure. All you need is to come to the wireframe and here. And then click on the Espaline command, right? Under which you have the spiral, helix, and other curves. But when you say this spline, now it says, give me the points through which this Espaline is going to pass. So before you do that, you need to create your point. So you click on the 3D point command. Let's say create one point here, and then go ahead and change some of these coordinates, right? So create the next point, and then go ahead and create the next point, and then another one, and another one, and another one, right? So you have a bunch of points that are completely in 3D space. As you can see, none of these 4 points are on the same plane. Each one has different XYZ values. There is no way to pass a single plane through them. And now I can use my Espaline command and say what are your points, and say point 1, point 2, point 3, and point 4. And look at this. This is a completely 3D Espaline, right? If you change the order of the points, then you get a different shape, right? So here, instead of going from point 1 to point 2, it could go to point 4 first. Then you would have a different shape, correct? So, and you can add points if you want to, before and after something, so you have a lot of control over that. So here, if I say, yeah, I want the first point to be point 1, but the next one to be 4, and then 3, and then 2, you would get a different Espaline, of course. And you can see clearly this is a 3D Espaline. And as I said, if you want, you can right click on any of these and say, hey, create a point after it or before it or anything. So let's say I want to create one point between maybe 3 and 4. So I click on 3, say I want a point after 3. And here I click somewhere, maybe change something. Right, so now I have that, and now I can add this guy if I want to. So it says add a point after 3. Sure, what is your point? Let's see if we can select point 5, right? Now, why can't I choose point 5? You are right. Why is it? Yes, you're right, because point 5 is created after creation of this Espaline. When I go and want to change something in the definition of the Espaline, I cannot refer to point 5, which is created after this Espaline. Remember I told you? You can never refer to stuff that were created after the current object. So if you want to be able to use point 5, you have to reorder it above Espaline 2, right? So you right click and say what? Reorder this and say put it before Espaline 4. Okay, and now it's there, but as you remember, now this Espaline 5 and the Espaline 2 and point 5 are both what? Kind of deactivated, right? They're hidden. Although they exist, but they're hidden. So I need to right click on them and say what? Define in work object, and now you can see them. Okay, now if I go into Espaline definition and I say I want to create something after point 3, add a point after, it says what point? I say point 5. Okay? Or no, I want to create something before that. I want to create a point before that. And I say I want to add 0.5 before that, right? Look. So now it's passing through all of them. So I can modify my 3D Espaline, add points before or after any points in that table. But the important thing is all of these points that I want to refer to and add them or remove them or not remove them, add them, they have to be defined ahead of time, above the Espaline in the tree. If not, I have to reorder them, just like I showed you here. So as I said, you can create a Espaline, a 3D Espaline, you can create helix, A spiral is just the 2D version of helix, no big deal. You can create arbitrary plane, arbitrary 3D points, and what? Arbitrary 3D lines. All you need is to provide the two endpoints or provide like normal to curve at the point. So let's say I want to create a line that is normal to this curve, and the support for it is like that. If you can, now most of the time it doesn't do it, and point is I want this point. Okay, and now you can see I have created a line normal to this curve on a plane parallel to XZ plane and at that point. Okay, so this is a completely 3D line. Okay, so we can get parallel curves on a surface, which are like cross section of the surface with a bunch of parallel planes that is used many times to basically extract a bunch of parallel curves so that you can later use them for a multi-section. Create a local axis that I need to talk about, and then geometric set, creating laws, curves, and so on. So I would like to stop the lecture at this point, and then let me at least show you these parallel curves. I'll talk about the rest of them later. Okay, so here is, if you have a surface and then you want to get parallel curves from this, or you want to get intersection of a plane with this, you can do that. Okay, so for example, let's say what is the intersection of this plane with this surface with the XY plane. So we click on intersection and say what is the intersection of that with the XY plane, and there we go. You see, the intersection is basically two curves that you can see here, and you can choose either both of them, or you can choose each one of them that has, it's like closer to something or far away from something, right? So say, well, I want the line segment that is closer to origin. I want to use a near far method, and it says, okay, near to what? Right? What is your reference element? And I say my reference element is origin. Which one is closer? And of course this one is closer to origin than the other line, so just keep that one. There we go. Or you could say, no, actually I just wanted what? I just wanted both line segments, right? So when you go there, it says keep all sub elements. And now you can see I got what? I got two lines here, correct? Let me change this a little bit so that you can see both lines better. Let me bring this guy down. There we go. So now you clearly can see both line segments. So this is intersection of one surface with one plane or with another surface. But instead of one plane with one surface, you can have several planes with one surface and get parallel curves basically. So say I want parallel curves, okay, and then it says on which support, say on this guy, and then here you provide some gap, and you see now I could create a curve parallel to that with the surface, or actually it's like cutting the surface with a plane that is 1 inch from the front side, right? Okay, so you see I can create that, or I can move it and basically create 3 inch, or if I want several of them, then I activate this option, says repeat object after OK. So create one at 1 inch, then when I say OK, now tell me how many more you want. And I say I want 4. There we go. Okay, so sometimes you need these kind of cross sections of the surface, parallel curves. Then you can use them to create, to combine them with other curves and create multi-sections. Okay, so you just want to extract, as I said, some cross sections from a surface, but not one, several, right? And use them for reverse engineering purposes. We'll talk about that in class.